Okay, we moved on from linear. Now we're going to work with graphing quadratics using a table of values. So this is the same idea of what we did with our linear question. The only difference is we have a variable to the power of 2, which makes it a quadratic. So it kind of looks like a U when you graph it. We have our table of values already kind of set up here. And we might have to extend it. We're not sure how far we're going to have to go. And we have our graph. Remember, when choosing a table of values, we usually look for values that are within our graph. We assume it's going to fall on this graph. Okay? I like to start around 0, so I'm going to use the exact same values I used with the linear equation. I'm going to solve for when x is -2, -1, 0, 1, and 2. So those are my x values. We're going to plug them into this equation here, this quadratic equation. And we're going to find y values. So what that means is we have our very first one when x is equal to -2. We have 3 plus y is equal to -2 squared. Okay? What is -2 squared?
4.
Yeah, positive 4. We have 3 plus y equals positive 4. I move that 3 over. It becomes negative. Y equals 1. So our very first coordinate is when x is 2. So remember, these two values are a coordinate. Think of it an x and a y value. We have -2 and 1. So we go down to our graph, -2 and 1. That's our first point on this graph. We're then going to take our next value. When x is -1, same equation. 3 plus 1 is equal to, and we replace x with -1. -1 squared is going to be what? 1.
Positive 1.
Okay? I'm going to go through this a little quicker since you guys have seen me go through the first one. The process is the same. When I move 3 over, it becomes negative. What's 1 subtract 3? -2. Okay? So our next coordinate is -2. So that's when 1 and -2. This is our next coordinate here. Same idea, x equals 0. 3 plus y is equal to 0 squared. Well, 0 squared is 0. When I move 3 over to the other side, it becomes negative. Y is -3. Here's our next coordinate. Or also our y-intercept is at -3. Okay? Now, this isn't linear, so we know there's going to be some kind of turning point known as the vertex. So I'm going to continue this process. There is a way to find out the pattern, but we're actually going to get into that when we use the textbook, so we won't talk about it today. We'll just continue this process. Same idea. I got to plug 1 in. I'm going to work a little faster. 1 squared is 1. Y equals 1 subtract 3. Y is -2. So when x is 1, my y value is -2. And finally, 3 plus y equals 2 squared is 4. Y equals 4 minus 3. Y is 1. So I'm going to try to follow this pattern. If you guys notice, we started here. We came down, we turned, and we started going up again. And essentially, this would just kind of continue like that. Okay? Here's our quadratic. Remember, it's known as a parabola when we graph it. Okay? So that's our table of values. So I should have wrote these numbers in, -2 and 1 again. These are all coordinates that we plot and then essentially just connect the dots to solve.